Hey, there we go. All right. Yeah. Okay. So to get started, as has been mentioned multiple times now, I'm Andy. I've been in the industry for about 17 plus years. New gig coming soon. Accepted an offer the other day. We'll be announcing it. But before this, I've worked as a DevOps manager and director of architecture at a couple startups, one of which achieved unicorn status. And in particular, I was pretty proud that using Backstage, Argo CD, Kubernetes, and Crossplane, we shifted from engineers taking, weeks to get new services into production to under 10 minutes. So a couple clicks, bam, in production. And also was pretty proud that a team of only 6 DevOps engineers was able to successfully support 60 plus developers and all that good stuff. In total, I think it's been 3, it might be 4 different organizations that have done cloud migrations according to best practices in highly compliant environments, using Kubernetes, as well as the original, AWS and GCP tooling and whatnot, to replatform and help re-architect into microservice architecture, which I can rant on why microservices are good some other time if anyone's interested. And then, as I mentioned too, I'm a huge CNCF fanboy, particularly the Backstage and Argo projects. I found to be very, very beneficial, and also do enjoy Knative as an easy way to get services out there. I think when we look at Kubernetes, we've heard more and more people say, and more articles on the internet that talk about the problems behind Kubernetes. I just read one that it is companies tend to spend more money, that they usually see a 25% cost increase when they switch to Kubernetes. And that this is that, they think that pure cloud native is cheaper because it's managed and there's less overhead. But then also, like they look at the penny pricing per execution of a Lambda versus the cost of, running a full VM or machine and that sort of thing. And that is kind of one of the things. The other thing is that you can kind of sum up these different issues, supposed issues. I'll say that it is too hard, that it's too much and too hard for developers to be able to ship code fast and easy with, that the complexity that it introduces makes it not stable, and that, it's also difficult to hire people. So that means that, we wind up running into an issue that, oh my God, someone left the organization who started the Kubernetes project and now we don't know what to do. In fact, I've started at a couple of organizations that have, fast tracked the hiring process for that very reason, that, there was a database that, a previous DevOps engineer moved to Kubernetes and they didn't configure it properly, and then it started crashing, daily, and no one knew how to fix it. So there was just this kind of gap that I think there are other reasons, but when you really distill it down, it kind of comes to these 2 things. I'm guessing, given this audience, everyone here knows what Kubernetes is, but just in case you're missing out, it can be simplified down as to just, it's an orchestration platform. That basically we need a way to say how and what runs where. So do we want it to run as a job? Do we want it to run as a web service? And then also, the actual physical locations of where we want these things to run. And the key difference is, rather than running as a, set of code on a given machine, it's running in a container. So, with the container being that we used to rely on, physical hardware and virtual machines that were effectively abstractions for full-fledged computers, that containers allow us to run just a single process in isolation with a extremely, specified set of resources. So all around, that also helps with the development process because you can replicate it locally. But when we're running things in production, where this really has not changed at all in the last 20, 30 years, is that we have some compute, we have a network, we have storage, we have user access, service to service access and monitoring. Plus, we could also talk about messaging and databases and things like this. But to simplify, here we are. So when we look at things in a production environment, we see that we started in a bare metal world where everything was kind of a specialized skill set, even, a specialized role, that you would have a machine that would do your DNS, a machine that, if you need to expand, you would buy another physical machine. You would have storage that if you needed more storage, you would buy more physical disks that would either be directly attached to the server running your workload or sitting in a SAN or NAS type of configuration. And then this was also the heyday of Active Directory and different LDAP servers and those sort of things. That was pretty much the go-to for most security concerns. And then monitoring was done by yet another physical machine that would have agents installed on the other physical machines and report back, or eventually be able to have quote unquote agentless observability. But it's more or less the same thing. Very static, difficult to scale, but it worked at the time. From a VM standpoint, this could be considered kind of the step into the cloud, because there's not as much of a difference between running VMs on top of a bare metal machine on-prem versus in the cloud. And so some of the same constructs still would exist when you have to do that, but effectively you're getting a higher level of abstraction. Now, similarly in the cloud now, there's a couple different ways we can talk about it. We can use cloud functions, lambdas, and those sort of things as our compute platform, which still require configuration, still require setup, still cost to execute, though it is more of a shared resource rather than the big purchase of a new machine, or even a new machine that can then be split between 4 different or 8 different or however many different VMs. And then our networks also shifted to become more abstracted and start focusing on a VPC and utilizing the different platform tools for cert provisioning and cert management. And now storage is even abstracted even further into different blob and document storage, as well as then these disks that just seemingly work. We tell it how much capacity we need and bam, you're there. You can provision IOPS nowadays on all the major platforms for any of your block storage. And it makes it easier to configure, but there's still very many parameters to configure with all this. We've just exchanged out the user access and OIDC and whatnot for IAM and OAuth 2 and those sort of things, and started using cloud native monitoring capabilities, or the monitoring capabilities of your choice. Now, when people started using Kubernetes, we first heard about all the problems with running Kubernetes. And I remember the good old days back in 2016 or 17, when I did my first, kind of foray into managing Kubernetes clusters and running workloads on them. And it would jam all the time with Helm 2 and, the old cert managers. It was crashing left and right because every upgrade was a major shift. But nonetheless, we're still talking about the same things. It's just a different abstraction. And especially now that we're running on EKS and we have all the managed Kubernetes, and most people are only focusing on the actual workloads and not the full administration of the master nodes and backend cluster, the control plane, we're at a point where, we're really able to effectively focus on the same things, how we want to configure the compute, the network storage, and all that. It's not that different, but yet we think it is. And from a developer experience, when we talk about CI/CD and code and how we manage things, this is an important point. We move from monoliths to microservices, point and click, to early IAC with Ansible and Chef and Puppet and all those things, to much more automated deployments, including Argo and a GitOps workflow. From a CI standpoint, instead of building on a build VM, most of the time now we're looking at building in a container, which is actually advantageous to developers to be able to have a replica environment on your local machine. And your code is protected from any knowledge of the surrounding environment if you do it right and follow 12-factor and whatnot. And then your IAC has changed too, that instead of using Ansible and Terraform, proprietary languages, we're talking piles of YAML, effectively, for better or worse. But that's what it is. But all of it is configuring Kubernetes services, ingresses, abstracts away the need to also create huge piles of infrastructure as code to provision and configure load balancers explicitly, to provision and configure and manage the the different racks of network switches and servers. All that stuff is taken away. So it actually is a lot more straightforward. So then where does the problem originate? We take away that it's all the same, more levels of abstraction and increasing levels of automation, which I will admit can create more risk. But we have changed the expectations for developers, and we also have not addressed issues with the knowledge gap. So before, for each of these different concerns was distinct roles. So we would have IT admin that would effectively be responsible for compute, network admin, storage admin, security. All these things were distinct roles within an organization with distinct certifications and distinct, um, you know, things we would expect people to do. Eventually, we started shifting into a DevOps culture, a DevOps mentality where, okay, so now we have a group of DevOps engineers, but so now they're all responsible for everything, with very little variability. Depending on the size of the organization, you get to the big organizations, you're going to have some more specific roles, but a lot of small and mid-sized organizations lump it all into the DevOps engineers roles. The full left shift organizations ideally say this becomes the responsibility of the individual developers, because we do want developers to take ownership of things. We want developers to be able to say, I can control my whole stack and I don't have to block things. I don't have to wait on IT to get around to it. But now, instead of I'm throwing it over the fence to a specialized role, it's kind of becoming more generic and higher levels of expectations, when there is a reality that we went from it works on my machine to actually starting to push back that no, that's not okay. You need, as a developer, to also be responsible for it working in production, which I think is a good thing. I think it's good for developers to know how to use containerization to develop and have it run anywhere. But we've not changed how we work. Most companies expect just as high a throughput as they ever have. Most organizations also don't realize that our national and international education systems aren't teaching a lot of modern cloud architecture and development paradigms. The number of developers that I work with who do not know how to build a Docker container, do not know how to write a Docker image, or even spin up a local database using Docker is huge. And it's a combination of interest as well as time. But most engineers really love building features and seeing them work and run, and aren't nearly as fascinated about just, getting it on the server and having it run. So there's this perception of, well, when I do a personal project, I can just drag and drop it onto a VM. Why can't I do that here? Or I push it up to a repo in Heroku and it automatically takes care of it for me. So effectively, especially for junior and mid-level developers, the knowledge gap and the set of expectations for what we expect them to learn is huge. And so this also then relates to the cost problem, because we don't know how our platforms are running, because we just don't understand them, so we over provision. But then also there's oftentimes less governance, because we've shifted from IT being the gatekeepers to also now saying, cool, as long as you can check it into Git and it passes some checks, you can deploy it without actually removing those resources. And this was also confirmed by the article I read recently. So what do we do about this? And I think that's where, we see a good shift in platform engineering, where it becomes important to have the developer portals where we can provide some levels of abstraction. But also, increasingly in this economy, we see that these are, not necessarily as well funded and can be under-resourced. That I know it's very difficult to have certain conversations with a product organization to justify why spending money here is worthwhile when it is not, something that is directly correlatable to a new feature bringing in more revenue. We have to say, well, we'll be able to ship faster, more reliable, less downtime, and those sort of things, that we have to take a secondary approach to talking about how this is valuable. But we also definitely do need to train more, and just help people understand that what we are doing is the same. It's just different technology and sliced differently. If we don't, we're going to realize that our organizations aren't able to keep up with other organizations, because the ones who do this right can move faster. Research has shown that. All DORA metrics show that. But it's not without the investment first. So with that, Kubernetes isn't really the problem. I think it's the expectations that we have from developers and the organizational structure that we need to be realistic with ourselves and understand that taking away DevOps or taking away IT is not a substitute for saying it's the same amount of work. We're just asking different people to do it without the knowledge to do it. So I think we're at time. So I don't know if there's any room for questions, but happy to answer. Go ahead.
Andy, just curious, a lot of people ask the question about Windows on Kubernetes, and I always get different answers. Just curious on what your feelings are here.
We have successfully run, and this was years ago, that we containerized a .NET 2 application and was able to get it running on EKS with Windows. I think nowadays there's a valid question about, can you migrate to .NET Core and run it in a Linux container? But
Right.
those legacy applications that function as a monolith, we were successfully able to do that. Though I will say the Active Directory and workload integration was a pain in the neck. So
Right, that makes sense.
That's the one problem.
Yeah, it's just a popular question now these days with all the VMware Broadcom business.
Yeah.
So it's not something that would come up so much in the past, but now it's coming up a lot. So
yeah, I think the one problem with Windows development tends to be that there are actually more processes getting kicked off in the background than you realize. And
Yep.
so you may want to adopt a mentality of, I'm not going to really treat this as a container. I mean, it is, but it isn't. And
Right.
so focus on even just giving it a dedicated node if you're not quite certain. In that case, start with over provisioning and then back it down. So
Got it.
yeah, Sandeep.
Hey, great presentation. So a lot of the pain points that you explained, we go through this ourselves. But I think my big problem with this is that when you're like a small to mid-sized company, even if you get the business to fund the platform team, the challenge is that if you end up picking the wrong technology or the wrong platform, you're still dead in the water. Like, this is something that we're going through, right? So we moved to Kubernetes before EKS was there. So which means we need to do keep up with the updates, keep up with like everything related to managing your own cluster.
Yep.
Now that there is EKS, it helps with some aspects of it, and you can easily go bring resources, right? But when you have your own version of things, it's extremely fine resources that can come in and start helping you. I think that's where that platform engineering team falls apart, is that you don't get results in the first 6 months. That team is done.
Yeah, and I think that's very true, and you have to look at it from a long-term perspective, because the platform engineering team should be focusing on resolving friction for developers. And because what I noticed is I've done this 3 times now, and each time it gets faster. What initially took almost a year, I was able to get, with a smaller team and just, a lot of bringing kind of what I knew to it, got the platform up in 2-3 months. And I think that that's where, as a community, we need to have a clearer path. And also, there are certain patterns that once you figure out how you like your repo laid out, it becomes pretty easy to manage updates and things like that. But that's something that doesn't even need to be org specific. That there could be these best practice templates out there that kind of like Gruntworks does for Terraform and stuff like that, that we should have that for Kubernetes as well, in my opinion. Because in that way, you see the pull request on the repo that you maybe forked, and then you just, cool, I update to that, knowing that's already been verified. Then you're not going to run into accidentally, wrecking your cluster. But I think there are some things that we can do to simplify the process overall, as well as make recommendations for here's a good place to start. Because every cluster, we install the same darn thing, so it doesn't need to be a head scratcher every time.
Okay. Andy, thank you so much. That was amazing. If you don't mind, can we direct some more questions to you in the Mighty Network channel in the discussion if anyone has any follow-up questions they want to continue to ask?